Hello, good evening everyone. Welcome to the Leitner Observatory Tuesday night public night live stream. Nice clear night tonight. Kind of cold, but not nearly as cold as last week. And I have a special stream tonight. I have a close approach tonight of the near-Earth asteroid 1994 PC1. And you might wonder, what a strange name. Why doesn't it have a nice mythological name like Apophis or Psyche or Eros or something like that? Why does it have this phone number name? Or why isn't it named after a celebrity like Tom Hanks or Meg Ryan? There are actually asteroids named after Tom Hanks and Meg Ryan. Let me turn on my camera here as it looks like the stream is healthy. There I am. Good evening, everyone. I'm nice and warm in the control room, and I'm controlling the 16-inch telescope, looking for this asteroid as it zooms by. It's moving really fast out there. I was looking at it a little bit earlier, and I think I found it. We'll see if we can find it again. It's moving super, super fast. Welcome, everyone. Let me log into the chat here. If anyone has any questions as we're doing this is live, so happy to try to answer any questions you might have about asteroids, the Leitner Observatory, anything in astronomy that you'd like to ask about. My name's Michael Fesa, and I'm the director here at the Leitner Observatory, and I run almost all of the Tuesday night public night sessions. We have been doing sessions in person up until end of December, and now with the Yale COVID alert level a little bit higher, we're doing some online streams instead of in person, but I'm hoping that we can switch over to in-person observing sessions outside when things get a little calmer and it gets a little bit warmer. That'll be nice as well. Let's see. Just checking my audio here. It looks like it's working. Okay, I'm assuming everything is still working then. Let's see here. Okay. All right, well, let's talk about this asteroid, 1994 PC1. I first saw that this asteroid was going to be interesting. It's going to be getting close. I was looking at spaceweather.com. And spaceweather.com is a great place to go look to learn about current solar activity. There are lots of sunspots on the sun. If there are any solar flares or any interesting activity. And down here at the bottom, there is a section on near-Earth asteroids. So near-Earth asteroids, potentially hazardous asteroids or space rocks larger than about 100 meters. There's still a lot of these that haven't been discovered. Asteroids about 10 meters to 100 meters to 200 meters or so that can come closer to the Earth than a 0.05 AU. That's 5% of the distance from the Earth to the Sun. So none of these are in a collision course with our planet. We know their orbits very well, but we're always finding new ones. And when a new asteroid is discovered, it is given a provisional designation. So it has a number and a letter sequence. The number is the year that it was discovered. And then the letter sequence has to do with the month that it was discovered in and the order in the year that it was discovered in. So it's kind of a code that the International Astronomy Union has set up to keep track of these provisional asteroids. Now, some of these may not be real asteroids. Sometimes space junk is discovered, or sometimes it's a spurious discovery. You have to observe the asteroid get close to the Earth or be at opposition relative to the Sun at least 3 times before you really know the orbit and you can recover it. You can predict when it's going to come around again, and then you can give it a name. So none of these asteroids on this list of upcoming close encounters have names. Although this one right here, 7482, does have an official designation, an official minor planet number 7482. And that's the one that we're looking at tonight. That's this 1994 PC1. I was excited to see it come around again because I actually did a research project on this asteroid. It's It's been a while, maybe 2010, 2011. Sometimes in the summers, I do projects, research projects with my students to study asteroids, often near-Earth asteroids, critical list asteroids, asteroids that the Minor Planet Center wants astronomers to observe and report observations of. I do this periodically. I was doing it in 2010, and that was when we looked at 1994 PC1. We're doing it again this summer for the Yale Summer Program in Astrophysics, so a little bit of an advertisement for this opportunity that we have at the observatory. This is a program for high school students. So if you know any high school students who are really into astronomy, really into astrophysics, want to do a fun research project studying near-Earth asteroids over the summer, you can apply for the program. Hopefully we're going to do it in person at the observatory in July and August of 2022. And if you go to the website yspa.yale.edu, that's where we have information about the program. Anyway, 1994 PC1. I started seeing news articles about it in the press because it is a big asteroid. It's, let's see, they're saying 3,280 feet in diameter. Let's look up actually what the JPL, the NASA designation is. They're just saying 0.526 kilometers in radius. So yeah, what is that, about 1.5 or so 1.5 kilometers in diameter. So that's pretty big, and it's getting quite close, so about 5 lunar distances from the Earth. So I saw recently a couple of astronomers tracking the asteroid, and it's actually quite bright right now. So you could potentially see it with your eye to an eyeball, your eye to the eyepiece of a telescope if you had a 8-inch or a 12-inch telescope. If we were open to the public tonight, we could potentially set up a telescope out on the observing deck and have photons go from the sun to the asteroid, go through the telescope and onto your eye. But what we're going to do is track it with the 16-inch telescope and see if we can see it moving relative to the background stars. Kind of like this image sequence from a telescope. Where is this? In Italy, I think. Yeah. So this was January 17th, so yesterday. And then it was actually at its closest approach this afternoon, Connecticut time, Eastern Standard Time. And so it's getting a little bit further away now. And if we actually look at its orbit, here is the predicted orbit from JPL. And actually, let's enlarge this. And that white oval that you see there is the orbit of this asteroid, 1994 PC1. The blue circle is the Earth's orbit, and then you can see the orbits of the other inner planets there. Now let's zoom in on where the Earth is right now. There's the Earth and the Moon right now, and there's the asteroid right now. So you can see it was a little bit closer earlier today when the Earth was a little bit further back in its orbit. We could go back a couple of hours and see that right about in there. It was a little bit closer, a little bit harder to see from the northern hemisphere because it has a very tilted orbit relative to either the orbit of the Earth or the equator of the Earth. So it's coming up from the southern skies and going north very quickly. Let's see if we can find it. So how would we potentially find it? Well, I use the JPL Horizons application to predict the ephemeris for the positions of asteroids or anything in the solar system. If anyone was watching my live stream of tracking the James Webb Space Telescope 2 weeks ago, I got the coordinates from JPL's Horizon system. Here's the link right here. You can also just Google JPL Horizons and you'll find it. And so I put in my location and the object I'm interested in getting coordinates for, and then the time range that I'm interested in. And I get a bunch of technical information that's mostly of interest to astronomers. But this RA and DEC right here, these 6 numbers basically, tell me its celestial latitude and longitude. It tells me where to point the telescope in the sky. I can also see the distance to it. Now, let's see, what time is it right now? The current time is 1:10 UTC. I'm interested in where it is. Here are the coordinates I'm interested in. And right at that moment, it's at a distance of 0.013 astronomical units. So that's about 1% of an AU. That's about 1 a little bit more than 1 million miles, like 1.2 million miles. And then we can see basically, is it moving towards us or away from us? It's moving away from us, and it's heading way up north. One thing about the shape of the orbit, you can see that it has a fairly elliptical orbit. It gets quite far from the sun way down here, and we're seeing it closer to perihelion. That's when it gets closest to the Earth, is at perihelion. And so it's moving quite fast. I noticed that actually in the space weather table. If you look at the velocities of these asteroids relative to the Earth, for 1994 PC1, it's moving at 20 kilometers per second. That's pretty fast. The Earth is already moving 30 kilometers per second in its orbit. So this is relative to the Earth. It's coming in at 20 kilometers per second. If we find it in the images, I could talk a little bit about what might happen if it were to collide with the Earth, or what we could do potentially to stop that from happening if we could predict it. Now, we know the orbit of this asteroid very well. It's been studied for decades. We know it's not even going to get as close as it was a couple of hours ago within the next century. So we have definitely 100 years of it not getting closer. But over the millions of years of future that the solar system has, we don't really know exactly what's going to happen to it, because very small changes to the orbit will cause it to change over time. And we do want to keep track of it. We want to keep an eye on it. Okay, let's go look for it at those coordinates. So I'm going to switch over to the control window for the 16-inch telescope. There you see a live view of the dome. And we are pointing at a patch of sky over here in the constellation of Pisces. Let's zoom in on that patch of sky and see what stars are there. So this is my star chart, right? And that yellow bullseye is where the telescope is pointed right now. And 2 minutes ago, the asteroid should have been right here in the middle of the image. So let's take some pictures. So we're going to start taking live pictures, 2-second exposure. All right, watch that little dot right there. Here comes the next 2-second exposure. Did it move? I think it's moving up and to the right. What do you think? Sometimes when I'm working with students and we're hunting for an asteroid, you know, I'll try to get them to zoom in on anything that might potentially be moving. We'll zoom in a little bit here and see if they can notice the motion. There it goes. That's it right there. It's moving quite fast. It's moving very fast. These images, each image is a 2-second long exposure with the camera through the telescope of a patch of sky in the constellation of Pisces. The asteroid is moving sort of up away from the horizon and to the right. And in the sky, that's to the north and to the west, sort of opposite the direction the Earth is orbiting. So we're kind of leaving the asteroid behind. We're kind of running around the track, or racing around the track of the Earth's orbit, if you like. The asteroid's a little bit further away. It's going more north than along with us. And so we're seeing it go sort of lag behind us, kind of head more towards the sun and up to the north. So that was much easier to find than the asteroid Apophis, which we looked for. When was that? Last April, a year ago, almost a year ago, coming up on a year ago, and and quite a bit easier, about the same difficulty as finding the James Webb Space Telescope, which we looked for 2 weeks ago and found it. And there it goes. It's tracking along. Now, I do want to actually save some images so that I can have data to share with my students and work on some projects. I can pretend to be Jennifer Lawrence in that movie and track plot the orbit and say, oh my goodness, it's going to hit us in 6 months. And it's not going to hit us. It's not going to hit us in 6 months. It might hit us in 1,000,000 years, but not in 6 months. Anyone seen that movie? I'm talking about, the movie is Just Look Up. I got to see it. I saw it maybe a week ago or so, and I enjoyed it, even though it was kind of silly. Now, the asteroid is sort of moving up out of my field of view. So I'm going to I'm going to command the computer to move the telescope up and to the right a little bit. So let me do that here. So there I am moving it a little bit. So the stars will shift in this next image. Okay, there it is right there. I kind of want to get it kind of down over here, so then I can take a sequence of images to save and do some analysis on later. So I'm going to nudge it even more. I'm going to sort of go up here. So telescope slew, that's how we move the telescope. And hopefully it's still going to be in the field of view in this next image. Yeah, I think it's that. There's some other bright stars in here now, which is nice. So we're looking now over here. So we got that. Those two stars are the same as those two stars. I'm pretty sure that's it. Where's my next image? Yeah, there it goes. Okay, I'm going to start saving some images here. So I'm going to do 2-second exposures. I'm going to take 50 images and save them to my computer so I can do some analysis on them later. One thing that's kind of interesting to try to do is take images over a few hours and see if the brightness of the asteroid changes. Because something that can happen with these asteroids, especially the small ones, is that they will tumble as they're orbiting around the sun. And so as they tumble, they reflect different amounts of light back to the Earth. So they get brighter and fainter, and you can measure the rotation rate of the asteroid. If you come up with a model of the shape of the asteroid, you can try and predict what the composition is at different points, different places on the asteroid. So there we go. Let me check the dome. So it looks like the telescope still pointed out the slit, but I'm going to rotate the slit a little bit here, get a little bit ahead of it. There we go. And I'm just going to watch these images come down. And this is a good chance if anyone has any questions for me. Type your questions in the chat, and I would be happy to answer them here in real time. There's the asteroid right there. It's quite bright. It's as bright as these other stars. I'm trying to think of something that I could describe it as being as bright as. It's not bright enough to see with the naked eye. You do need a telescope. I would say it's just a little bit too faint to see with binoculars. But I would say if you had a 6-inch or an 8-inch telescope, that's the diameter of the mirror, and if you knew where to point in the right place and you had dark skies, that's something that we're lacking here in New Haven. Skies aren't very dark. Of course, with a digital camera and a big telescope, we can effectively subtract off the sky brightness. If I were to show you more what the sky brightness looks like, adjust the brightness and contrast here. We get an image more like that. You can still see the asteroid, but we can sort of subtract off the light from the background sky, and that allows us to do some advanced imaging and astronomy projects, even though we are here in the city. Once I finish this sequence of images, I'm on image 20 of 50. I'll probably do another sequence and talk a little bit about planetary defense. So how we're looking to track these near-Earth asteroids, and if we discovered a new one that was a potential hazard to the Earth, what could we do about it? There are things that we could actually do, and we've actually made a lot of progress in the last 10, 20 years in terms of discovering these potentially hazardous asteroids, and in terms of coming up with schemes that could work to potentially deflect or speed up or slow down an asteroid so that it would not be a threat to Earth. There it goes, flying by. Let's see if I have any questions in the chat. Not seeing any new questions. I saw some questions from earlier today. The asteroid already made its pass. Yes, so it made its pass. The Earth and the asteroid are both orbiting the sun at tens of kilometers per second, 30 kilometers per second for the Earth and something like 50 kilometers per second for the asteroid. But of course, the size of the orbit is huge, and the distance to the asteroid is more than 1 million miles. So it's not something that happens like that, where the asteroid streaks across the sky like a shooting star or something like that. You know, it's out there in space and we can see it moving. It's moving very fast from my point of view as someone who studied asteroids motions in the past or asteroid orbits in the past. This thing is zooming across the sky. Of course, the close flyby of Apophis that's going to happen in April of 2029, that will be very, very fast. And it will be bright enough that you will be able to see it with the naked eye. So it's definitely something worth putting on your calendar and attempting to go out and see if it's clear on April 13th, 2029. All right, I'm almost done with my image sequence, and the asteroid is a little bit past the center of the field of view. So when this sequence finishes, I'm going to nudge the telescope up and do another sequence. And I will take these images and make them into an animation, make a movie out of the sequence of images, and post that in the description for this video when it goes up on YouTube, and maybe post it on Twitter as well. The Leitner Observatory Twitter account is LFOP, so twitter.com/LFOP is where you can see images that we're taking at the observatory. We just recently got an Instagram account, one of the students set up, so I should post it there as well. So on Instagram, our handle is lfop.yale, is where you can find us on Instagram. Planet Noble, 1.5 kilometers seems large enough to worry about. Yes, it is large enough to worry about. So let me start another sequence here, and we can talk about how bad that is. There it goes right there. So I'm going to nudge the telescope up here. So move the telescope. And I'm going to start taking another sequence of images. Okay, so now we're up here. The field of view, by the way, we're looking at a patch of sky that's about the size of the full moon. So it's moved through the size of the full moon in, how long have I been talking? For 10 minutes or so, 10 or 12 minutes. It's moved that far. So we just want to confirm that it's in the field of view here. So I think it's that guy right there. There it goes. Oh, no, that's it right there. I saw it move. So what star is that? That must be trying to match. So I think those two stars are the same as those two stars there. And so the asteroid is flying by right about there. That star right there is quite bright. So it's not very bright in my chart, but it's quite bright in the image. Okay, so we'll let that image. How quickly does the telescope move when you change its center? It depends on how far you're moving. There is a limit to how fast the telescope can move around when you're pointing at different places in the sky. But you saw the yellow bullseye move over. It took about a second for it to move that degree from the old location to the new location. If I were to tell it to flip across the sky and point at Orion or point at the full moon way over in the east, we're still looking sort of in the direction of Pisces there. If I were to tell the telescope to go point at the moon, it would probably take about 2 minutes or so for it to move around. We do actually command it to move slower when it's cold because there's some mechanical friction in the telescope that's a little bit worse when it's cold, and sometimes it freezes up. So we move it more slowly when it's cold than when it's warm. Will the close paths change its orbit appreciably? No. So it's not that close of a pass, 5 lunar distances. It's moving very fast, 20 kilometers per second relative to the Earth. So the Earth's gravity will have a tiny effect on its orbit. That's something you can model. You can make a model of it and see how much it is, but not enough to, for example, really deflect it by more than deflect it by any noticeable angle. When Apophis flies by in 2029, it's going to be deflected by some angle of degrees or tens of degrees. No one knows exactly how much it's going to be deflected. But this asteroid has been deflected a tiny, tiny, tiny fraction of a degree because of the Earth's gravity. But of course, all the asteroids orbiting the sun are constantly being tugged on by Jupiter, or the Earth if it gets close to Earth, or Venus if it gets close to Venus. And those have small effects that build up over time. And that's one of the reasons why this asteroid is a potentially hazardous object. We don't know, it's hard to predict how its orbit is going to change 1 million years, 10 million years, 100 million years from now. And we do get hit by things. We do get hit by asteroids. And so actually, if I switch over to this image that I searched for and uploaded before I started the stream, this is a plot of the frequency of asteroid impacts of different diameters. So how often does the Earth get hit by something this big? How much energy is released when something that big hits us? The energy released is going to be proportional to the mass and then the speed squared when it comes in and hits us. That's the kinetic energy of the asteroid. So if you raise the size, the mass is going to go up by the cube of the size, right? The volume goes up as the cube of the diameter. So the mass is going to go up as the cube, and so the energy deposited is going to go up as the cube of the diameter of the asteroid. Anyway, this is a logarithmic plot. So we go 1 year, 100 years, 10,000 years, 1 million years, 100 million years of frequency, and then here we are going up in size in this direction. So this asteroid is about 1.5, a little bit less than that, kilometers across. So it's going to be right about here. That's a lot of energy. Megatons of TNT, that's like 100,000 megatons of TNT. That's a lot. I'm trying to think, the biggest bomb, the biggest nuclear weapon ever detonated on the Earth was the Tsar Bomba. There was a nuclear test by the Soviets in the 1960s. And that basically means the king of bombs. Not the mother, but the king of the bombs. And I think it was it 50 megatons? I think it was 50 megatons. I should look it up. And so, this is thousands of those going off if it hit us. You expect something like that to hit us, though, every million years or so, right? And so maybe this one's going to hit us in 1 million years. Maybe this one has our number. And it would be bad. It wouldn't quite cause extinction of life. This is not quite as bad as the 10-kilometer comet that's in that movie, Just Look Up. Or, the 10-kilometer comet that hit Mexico 65 million years ago and led to the extinction of the dinosaurs. The frequency for asteroids that big is about every 100 million years. So you see, it's not a question of if an asteroid or a comet is going to hit us. It's a question of when. And as you go to bigger asteroids, it's much less common. Small asteroids hit us all the time. Something like the thing that caused the Chelyabinsk fireball a couple of years ago. What was it? Actually, it was 2013. That one was probably 10 or 12 meters across. So that hits us every few years, maybe every 10 years we get one like that. And then you have the Tunguska event. That was something that was about 30 or 40 meters across. That's about every 1,000 years or so. Something the size of the asteroid that created Meteor Crater in Arizona, that was 50,000 years ago. And that asteroid was like 50 meters or so across. So that's sort of in the 10,000 year frequency range and so forth. What's the difference between an asteroid and a comet? Well, asteroids are these rocky and sometimes metallic objects that orbit close into the sun, between the orbit of Mars and Jupiter, mostly. Some of them could get close to the Earth, like this one. Some of them get close to Mars. Some of them get close to Jupiter. A comet is an older object. It's an object that's mostly made of ice, or it has a much higher composition of ice than asteroids. And they orbit much, much further out. They formed much further out in the solar system, maybe 100,000 AU, 100,000 times the distance from the Earth to the sun. They're mostly out in what we call the Oort cloud. They fall into the inner solar system sometimes, and we discover new comets all the time because of that. They're actually a little bit more dangerous than the asteroids because of that, because we know where all the asteroids that are bigger than about a kilometer or a few kilometers in diameter are. We know their orbits fairly well. There are a lot of smaller asteroids, maybe 100 meters or so, that have not been discovered yet. So there are missions to discover them, and there are telescopes looking at the sky every night, discovering new small asteroids, plotting the orbits. 100 meters, if one hit us, it would be bad. We're down here in the thousands of megatons. It would be bad, especially if it hit a populated area or maybe hit the ocean and caused a tsunami. That would be bad. So it's definitely worth tracking these asteroids. But comets are falling in all the time. New ones are being discovered all the time. There's a really big comet discovered just last year, but it's not going to get very close to us. So yeah, discovering that's one thing about that movie, Just Look Up, that I think is more accurate, that they decided to make the impactor a comet rather than an asteroid, because a 10-kilometer asteroid, you wouldn't expect to find one. A 10-kilometer comet, most of them are not that big, but that could potentially happen. Let's see. I was hoping this would be visible to the eye. No, not this one. A meteor, yeah. Meteors are tiny, tiny. They're like pea-sized asteroids. We don't call them asteroids. We call them meteoroids. But they're super, super tiny things. So they come in and create a plasma trail and light up the sky, and you can see them. A lot of them, or some of them, are associated with comet orbits. And so you get annual, that's what I'm trying to say, annual meteor showers, like the Leonids in November, or my favorite, the Perseids in August. Yeah. Am I a Taurus? No, I'm a Leo. Is there a site with meteor numbers, names with predicted observing? Yeah, so the J-PAL Horizons is a place where you can go if you want to look up a specific asteroid, the orbit of a particular asteroid. You can plot the orbit like I did here. Some really nice tools for teaching astronomy and for doing observational astronomy. And if you're interested in what asteroids are getting close soon, I recommend spaceweather.com. So spaceweather.com tells you, mostly it's about solar flares and the aurora. It can give you predictions of when there might be an aurora near you at your latitude, wherever you are. And down here near the bottom is the information about near-Earth asteroids. I guess in terms of space weather, that's analogous to space hail. Meteoroids potentially coming down from these asteroids, or these asteroids getting close. And you can see there have been, today is the January 18th, and we're talking about the flyby of this one right here, 1994 PC1. And it's interesting because it's so big. 1732. So space weather is reporting 1.7 kilometers diameter. So it was a little bit low on my estimate. But there have been other smaller ones. These have all been discovered in 2022, except for that one in 2021. And they're like 20, 30, 50 meters across. That's not very big, right? 50 meters, half the size of a football field. 10 meters, what's something that's 10 meters? A house. So they're not that big, and they're not moving super fast relative to the Earth, although there's one at 20 kilometers per second. Some of them are getting closer than the one tonight. Like here's one that got within two times the distance to the moon. Are there any other coming up after the 18th? There aren't any really big ones coming up until March, when we have a 750 meter diameter asteroid flying by at, again, well, no, here's the distance, 4 times the distance to the moon. What are some really close ones? What's the closest one coming up in the next few months? None closer than the moon. So, we could wait and see if any new ones are discovered by astronomers that might be coming closer, but I don't see any coming up. Let's see, do we know if major asteroids have impacted with Mars? Yes, they definitely have. We haven't seen it happen, but you see craters on Mars, of course, and you can find meteorites on the Earth that have clearly come from Mars. So something big hit Mars, knocked a chunk of Mars off, and orbited around the sun for millions of years, and then some bits fell to the Earth. So we have impact debris from Mars on the Earth. You can find meteorites that clearly, based on their composition, came from the crust of Mars. Does this asteroid have trillions of dollars of precious metals? Well, it's a rocky asteroid. It's a stony asteroid. So probably it's mostly, rock, silicon and oxygen. But it'll have trace amounts of iron and nickel and platinum and gold and all of that sort of stuff. Yeah, that was actually one thing that was not very realistic about the movie was these comets. This comet is mostly ice and hydrogen and cyanide and rock, and rock, of course. There are not a lot of heavy elements. There are asteroids, they're less common, but there are asteroids that are mostly made of metal. And those are the ones that are interesting for potentially future asteroid mining. Maybe 15% or so of the asteroids are iron nickel metallic asteroids. So they're actually made of the cores of protoplanets that were smashed to pieces. So the stony, rocky asteroids like this one, they're made of the crust and the mantle of protoplanets. Whereas these iron nickel meteorites, metallic meteorites, Psyche is a really good example. And I remember Psyche asteroid. I remember a few years ago, NASA's set to explore a massive metal asteroid. Some years ago, there was someone who had calculated the money, like the value of the metals within Psyche, and it was trillions of dollars. Oh no, here we go. 10,000 quadrillion dollars. If you could find some way to go get it safely to the Earth and not flood the market with all of those metals, you could be a quadrillionaire. Actually, that's 10,000. What's after quadrillion? Quintillion. You could be a 10 quintillionaire if you could harvest the asteroid Psyche and bring it to the Earth safely. Okay, well, let's see. Let me go back to the telescope and see if anything's happening. My images are done, of course, and I think the asteroid has already moved out of the field of view. So I don't think I'm going to keep chasing it. We got a nice view, and I have enough images that I can make an animation, and I can measure its position and plot the trajectory and so forth in the future. So I think I'm going to sign off there. If anyone else has any last questions for me. Like I said last week, probably not going to do live streams every Tuesday night. Probably will do some when it's clear and there's something interesting to look at in the sky. We have a nice full moon tonight. That's actually making the sky a little bit brighter as well. So we'll see next week if it's clear and if there's anything interesting to look at. Maybe we'll do a live stream. I'm hoping, I don't have any news about this, but I'm hoping that in a few weeks, a month or so, classes are starting next week at Yale, but I'm hoping that in a few weeks we'll be able to have in-person observing sessions again here at the Leitner Observatory. So if you're in Connecticut, if you're in New Haven, check our Twitter feed, check our website. The website is leitnerobservatory.yale.edu. So just like on the channel name, Leitner Observatory. And like I said, our Twitter account is LFOP, so you can follow us there and DM us or add us. You're also welcome to send me an email. I give out my email, my Yale email, if anyone has any questions, michael.faison, so Faison @yale.edu, and happy to connect with people who have questions about astronomy, about the Leitner Observatory, about asteroids, about that summer research program that I mentioned for high school students, which we call YSPA, the Yale Summer Program in Astrophysics. Looking forward to doing it in person this year after not doing it for 2 years. So applications for that program are due on March 5th if you know a high schooler who's into astronomy. All right, thanks everyone for tuning in tonight, and wish you the best of health, clear skies, and I'll see you next time. All right, good night.